Namaskar, my dear friends. Let us talk about how we can design LED indicator schematics that we use in microcontroller circuits or FPGA circuits, and how we can simulate them in NI Multisim. So there are a lot of like simulation tool where we can make use of them to design our circuit and evaluate them. So let us say, for example, I have a voltage source of 5 volt for my FPGA or 3.3 volt. So you would have seen that this is my 5 volt indicator, like 5 volt I have supplied here with one resistance, and this is my LED. So this is the circuit design that we have done in our like system circuits. We want to simulate this so that we can see whether the LED is glowing or not. Similar to that, we have 3.3 volt indicator, we have 12 volt indicator, right? So for 12 volt, you can see the resistance is increased so that the current can be limited. At the same time, this is 2.8 volt. So the thing that we have to take care of is the LED has some drop, which is, let us say, 2.3 volt or 2.7 volt or something, right? So as long as the supply voltage is more than this drop, this way it is fine. However, if my voltage is 1.8 volt or 1 volt, or like 1 volt core voltage is there, so in that case it is very difficult to have an LED indicator for your power supply. So what do? We utilize transistors like MOSFET or NPN transistor. So what is going to happen? We have main power supply, let us say 3.3 volt, that will be driving the LED, and this will happen only when my power supply 1 volt is available. So this 1 volt will be used to drive this particular transistor, to bias this NPN junction, and this is how it will start glowing. All right. Similar to that, 1.2 volt also is done, or 1.8 volt is also done. Let us say some more circuits are there. We have 1.8 volt, 1.1 volt. So all these indicators are utilized in our FPGA circuits. So we need to have an understanding how to make use of our simulator to do the job. Similar to that, we can have another kind of LEDs. Let us say this is going to get connected to my microcontroller or FPGA, right? IOs. So whenever my FPGA IO will be low, this will start glowing. Similar to that, whenever the FPGA IO will be high, this will start glowing because this is connected from microcontroller IO. So this is acting as sync pin and this is acting as source pin, right? Like FPGA IO will be acting as a source for this LED, and this will be acting as a sink for this LED. Whenever there is a high amount of current required to drive the LED, what do? We drive through a MOSFET or transistor, as I told you just now. So what we'll do is we'll try to simulate all these circuits in Multisim, and we'll see whether we are able to do that job or not. So let us open Multisim. All right. As you can see here, we have a voltage supply, let us say VCC. Then we have added one resistor 220 ohm, and we have an LED, blue LED indicator is there. If you want, you can change the LED color as well, not a problem. Okay. So I'll just make it this. Yeah. If you want, you can delete this and let us put some other LED. Place component. We will go to diodes and then LED. Let us say we want to have orange LED for our indication. So this will be my orange LED, right? Now just connect it like this. Understood? Got it? So what I have done is I have put a voltage probe at this node, which will be 5 volt. Voltage probe at this node, which will be after the drop across this LED, what will be the voltage that will be appearing? And what is the current flowing in this branch that will also be appearing? So let us run this. You don't have to do anything. You just have to run it. So you can see 13 milliampere is the current that is flowing through this branch, and my LED is glowing. You switch off, my LED will be off, right? Or let us say run it again. My LED is glowing. When it is not glowing, let me just tell you, let us say it is 0. Okay. So now you run it, my LED is off. Understood? So voltage is 0, LED is off. Now voltage will be 5 volt, LED will be glowing. Understood? So simulation must be switched off, then only it will start. So as you can see, it is running. Another way is, let me give you another circuit. Let us say we have a transistor and our voltage was just 1 volt. So this 1 volt will be not able to drive this LED. So what I have done is I have connected a source of 5 volt, and this will be driving the LED, but this will be acting as a enable signal. So whenever my voltage source is enabled, it will be started, right? So let us see that. You can see this is glowing. Now whenever my voltage source becomes 0, let us say this becomes 0. So now it will not glow. So this is open circuit. Understood? You can see this is blank. So when it is filled, it is glowing, and when it is not filled, it is off. So let me just make it 1 volt again. So through 1 volt core voltage indicator, if you want to have an LED indicator, you can design circuit like this. Understood? MOSFET you cannot use because MOSFET gate may not be able to switch down by 1 volt. So that's the reason I'm not putting a MOSFET here. If you want, you can use a voltage, like a digital voltage, so that you can have a pulse here, and whenever it is on, it will be glowing. Whenever it is off, it is not glowing. If you want, you can vary this voltage to, let us say, 1.2 volt indicator. You can use this, not a problem. Same circuit will do. You have some other voltage also. What was that? 1.5 volt. So you have 5 circuits: 1 volt, 1.2 volt, 1.5 volt. Then we have 1.8 volt as well. So all these voltage levels, you can make a note of this. Okay, again it is glowing. And then we have 2.2 volt, 2.5 volt. Generally this is my logic voltage, 2.5 volt. So 2.5 volt will also be doing, not a problem. For 3.3 volt and all, what you can do is you can directly connect, as I told you, like this. So let us say this one is 3.3 volt. It will still do the job. 3.3. Let us run it and let's see whether it glows or not. So yes, it is glowing. Understood? But if you make it 1.8, it will not glow, because 1.8, more than 1.8 is the voltage drop only. So it will not glow. See, it is not glowing. Understood? So you have to understand what is the driving voltage, then only you will be able to run it. Okay. Now let me give you another examples that we saw. So let's say like this, how it can, like sync, or how it can source. So for that, what we can do is we can use pulse waveform, okay, or pulse source. So in pulse source, what I have done is, this is my continuous source that is there connected, like 5 volt, and whenever my microcontroller signal will go low, it will start glowing. Whenever it is going high, it will not glow. So what I have done is I have added one pulse voltage with initial value of 0, pulse value of 5 volt, and I have put 1 second pulse width. Okay, so whenever 1 second it is high, and another 1 second it will be low. So this is my period. So now if I run it, what is going to happen? It will glow, switch off, glow, switch off. Like that it will be happening for 1 second. Okay. Similar circuit you can do. What you can do is, I will use this circuit. Let us say I will use this circuit here. Okay. Now this voltage will be acting as a source. Okay. So what I will do is Control C, ground, I need one here. Okay, so whenever this will be high, this guy will be glowing, and whenever this will be low, this will be not glowing. So I'll just put it little down. So this is my current monitor. This is the voltage level at this location and this location. Why don't we do one thing? We will change this color of LED so that you can have a proper view. So let us change it to red color. Okay. So this is my LED color. So what is going to happen? Whenever my source voltage or pulse width is high, this will be glowing, and whenever this is low, this will be not glowing. And but here it will be low, this will be glowing. Okay. So let us run it. Okay. So once it is high, and once it is low it will be glowing, and once it is that time it will be high. Okay, so you can see this is glowing alternatively. Got it? Alright guys, so hope you have a good understanding of how you can simulate an LED in multi-sim simulator, or various other circuit design simulators are available, and if you want you can make use of them. But what I found is this is one of the best circuit design simulator where you can make use of very small circuits like transistor based circuits or MOSFET based circuits, and make use of them, like how to design those circuits. So if you do have any questions or anything that you want to make use of simulations and then try out, and after that you want to go ahead for your actual circuit design, you can put down your queries in the comment box and we shall be able to give you answers. Thank you.